Hello and welcome to the .NET Language and Runtime Community Stand-Up. Hopefully we are now live, unless I messed up something spectacularly again. So we're using different software today, so it's going to be a fun exercise for all of us, but hopefully it's much easier for us and we can actually focus on the broadcast for once. And I'm pretty sure Philip will ask me in 2 minutes whether we are live. So let's do some quick round of introductions so that people know who we are. So my name is Emil Landworth. I'm a program manager on the .NET platform team.
Who's next?
And one of you has to go next.
Let's go.
Rich.
Yeah, I'm on the .NET Runtime team. Yeah, that's it.
I'm Kathleen Dollard, and I'm a PM working with the .NET SDK, CLI, templates, Visual Basic, a few other things. So that's me.
I'm Philip Carter. I work on our languages and tooling, focusing on F#, a little bit of C#, and I like to pester Emo by asking him if we're live every single time we do this.
Yes,
and that's because actually, like, I needed to ask that a couple of times because he didn't quite press the button, and like we would start talking and that stuff. So it's just a habit now.
You're not wrong. Like last time we did the API review on Tuesday, I was halfway through 2 issues before I pressed the start live button. That was unfortunate, but hey, happens.
Should I be in every one of your meetings just to ask you that question?
I'd like to pester Emo to see if he's published his blog post on .NET PFMs yet.
Oh yeah, that's true. When is that thing coming out, dude? Did you write that?
Yeah, I need to finish it. I mean, in fairness, the blog post is already in PR for like a while, so it's not like I haven't written the majority of it yet. So I just have to address some comments.
So you're saying
you guys have opinions, as it turns out.
No, it's coming out, so people are going to be confused if we don't get that blog post out.
Yeah, well, yeah, that's totally true. So speaking of confusion, so what's our agenda for today? So I have a few things I want to talk about. I think Rich had a few things to talk about. Philip gave me a list, which I no longer remember because it was something with F#. And I think Kathleen also had maybe 1 or 2 things she wanted to talk about.
Well, there's a couple of announcements I can make. I'm pretty slow today. I mean, I don't have any demos or anything. You guys can take that.
Sounds great. So who wants to go first? Rich, do you want to go first?
Okay, that we can do that. Let's see if I can figure out the screen sharing thing. So yeah, so I'm okay. Share screen. Share. Okay, let's try the tab sharing and see if that works. So I've been there we go. Is that working? Yeah.
Yep.
Wow, that's cool. So I've been one of the things I work on is IoT. I said I work on the runtime, but I work on lots of other things too. So one of the things that I've been working on is IoT, Raspberry Pi type stuff. So I've been working on a few pull requests, and let's see if I can switch to. Okay, this isn't going to work quite as. I'm gonna have to share my whole browser, otherwise this is going to be silly. Okay, share entire screen. Okay, this is if I had two monitors, then this would work better. Okay, can you see what I'm seeing?
Not quite yet. No, I edited, so now we should all be seeing it.
Okay, you see basically the same thing you saw before?
Yeah, but now we see the whole browser.
Okay, that's cool. That's totally fine. Okay, so I've been working on a couple of PRs, and then to make this a little more real. So this is the MBI 5027, and this is a shift register. So we now have it's still in PR as you see from the last page, but so we now have APIs for targeting this particular device. And what this enables you to do is this is a 16-bit shift register. So there's actually 16 of those legs connect to LEDs, and it allows you to control 16 LEDs in weird and wonderful ways. The super cool thing is it has open short circuit detection, which means that you can actually in code find out if all the LEDs are working correctly. And so that means like if you had like a sign on a highway, you obviously, and you know that motorists are supposed to look at, then you could know, this device could know that something's gone wrong. It could like, send that to a cloud service, and then someone could know that they should go and repair it. This one is the SN74HC595, which is actually probably the most popular shift register. This one's 8-bit, so 8 of these legs can make LEDs work. This one actually, I merged the PR for this a while ago, so and actually I'm making some changes to it. Another one is Charlieplex binding. So this is kind of an insane thing. Charlieplex binding doesn't require an integrated circuit at all. What it is like a way of, see if there's a good picture. It's a way of doing something, creating these kind of fake circuits in software that do strange things. And the weird thing is only one of the LEDs can be lit at once, which would seem like a problem, but isn't, because you change which LED is on many times a second, and then the eye mainly can't tell that's going on. And the biggest problem with these is it's got this like crazy scheme for laying out the LEDs, and you have to know which ones of the pins you should light up at any one time. So it's like basically a network address type of problem. So anyway, the binding takes care of all of that for you. And the last thing is the interface called iWritable pin segment, and it's basically an abstraction that is intended to enable you to use any of the things that I just showed you with like really simple code. So if we like, see if there's a README file for this, I should know since I did this. No, apparently not. Never got that far. Anyway, it's a super simple interface. It should be here. There.
It's written by you apparently, right?
Yeah, I know. Because I wrote this a little while ago. Right now, it only has 2 members on it: length and right. And then so it's super simple. And then you can interact with any one of those 2 chips or the Charlieplexing thing. So anyway, that's what I wanted to show. So I'm got a couple PRs for those right now, and I'm about 3/4 of the way through a blog post explaining all of this.
Sounds like my blog post.
Another blog post that is stuck.
Yeah, yeah. I've been working on it almost every day. This is my summer project.
Yeah.
So speaking of which, so like, what is the story for this? So right now, this is, as you said, like it's something that you work on your spare time. So does it mean it does not ship with the platform itself? It's like a bunch of NuGet packages that I can add to my project?
Yeah. So I guess I'll show this as well. Okay, let's go back to here. Share screen. Share entire screen. Okay. Super professional.
It's super simple now, so it's using it.
Yeah. So if we go to NuGet.org, so we have 2 NuGet packages. Yeah, I think it's this. Oh, it's the other way around. So this is our main NuGet package. And so this has like GPIO, PWM, I2C, and SPI in it. So those are like the protocol level APIs, and that works on both Windows and Linux. And this one is like a supported package, just like all the other system.packages. And then we have another one called IoT.device.binding, something like that. Yeah. And so this one is actually more of a community supported package. And it has like all those device bindings in that I just showed with you. And I'll show you where those live. This will obviously be in the blog post too. It happens to be this link. And so these are all the device bindings that are in there. So you can see, and these are all have been community contributed. And so you can see there's like actually a fair number of these. So you basically buy some part. So we'll just pick something at random. Like I don't even know if I've ever opened this one, radio receiver. And it basically says this is the code. And then you click on this data sheet, which apparently must be massive because it's okay. We'll look at a different one. This is an IoT expander. Some of them have pictures.
Mm-hmm.
So anyway, basically, you would know that you need this because your project would kind of demand something. So we have a ton of these device bindings. So super cool.
That is awesome stuff. And like, so I assume that means by the time we ship, there will be some NuGet packages that I can play with, right?
Well, the NuGet packages are already there. They're just in constant development. They don't specifically relate to the .NET schedule. So
Gotcha.
I'm working with the team right now that there's just a few of us, and so the idea is we'll get those PRs that I've been working on merged, and then we'll publish a new version of the package. Then I'll publish the blog post because then everything will be coherent. I really dislike telling people like, oh, you need to use this preview one because we haven't yet finished it. If we can kind of just finish the whole process, then we can skip that whole section of the blog post.
Yeah, that makes sense. I just want to highlight this one comment from Douglas. He works at Texas Instruments, and he was just amused that he's one of our chips. It's cool stuff. I mean, like we have rarely done hardware with .NET, right? So that's a relatively new thing for us. I mean, of course, we support CPU architectures, but like actually talking to real hardware is super cool.
Yeah, I've learned. Go ahead, Kathleen.
Oh no, I was just going to say I love Wolfhound Jesse's understatement that he likes to stream because he never knows what the topic will be, which is that's all I want to comment on. That was very great.
Yeah, like working at this level, a couple things that have been different for me. One is like the compiler and the debugger provide, they're not quite as helpful as they are with other types of programming. It's actually more like microservices to a degree, except even slightly worse. So for example, I use logging a ton to like find out what the whole state of my environment is. Like setting a breakpoint at a given time isn't necessarily all that useful, at least for me. And then the other thing is the style of code you have to write. Like, in the shift registers, for example, there's a fair bit of bit shifting at play. And so it's not that I don't know what that is, but I'm not used to having to do that kind of thing. And not just bit shifting, but also like creating masks and anding values with those masks and using binary literals. So super cool. Oops.
Right.
Makes sense. Yeah, Philip has a focus hunting issues with his camera. Like he keeps blurring in and blurring out, which is interesting.
It's still doing it? No, it does it all the time. Sometimes if I stick my thumb in front of it.
I actually think it's a beauty filter. The camera detects that it needs some blur to make you look less jarring. All right, so like I'll just volunteer myself to go next because I only have some, few things as well. So a few things first. So we have this API review process where we review APIs from the community. And so I wrote a website here that you can go to, apireview.net, which basically have some helpful links to go to. What's our review process? What are the guidelines that we are using? And we also have, all the design reviews that we do are uploaded to YouTube. So there's like literally hours and hours of reviews you can watch where we pontificate over API design if you're into that sort of stuff. But the interesting thing here is that it's not a bug right now. So we literally have finished the API review backlog as of last Tuesday. And so we are now down to 0, which means if you file an issue right now, you will immediately be at the top of the queue, so which is quite nice. And so we had quite a deep backlog because during the 2.0 timeframe, we changed our strategy, as you're probably aware, where we added a lot of APIs that existed in .NET Framework to .NET Core. And that meant we basically didn't work on anything new. We only added existing APIs, and that kept us busy for a while. And after 2.0 shipped, of course, we were working towards finishing that backlog and reviewing more and more API suggestions that people had. But Normally we only meet once a week for 2 hours, and then we basically started to do it 3 times a week for 2 hours for, I think 3 or 4 months now, to actually get through it, and we finally finished it. So I'm actually quite happy that now we are at the point where if people file review requests, we can actually review them in a timely fashion rather than 3 years later, right? I mean, there literally were plenty of review requests that, were several years old because we haven't had a chance reviewing it yet. So I'm actually quite happy about it, and it also means that we have much more of a timely loop moving forward.
So what changed? Why did you have a backlog for so long and now you don't?
Yeah, so as I said, one of the things is we basically doing 2.0, we were so busy just adding existing stuff, right? And so the entire engineering team was basically mostly occupied with porting. And so we only had very, very few resources to work on net new APIs. And after 2.0 shipped, I mean, then we added WinForms and WPF in 3.0, which was a major work item for us. And so we didn't have a lot of resources towards net new stuff. And then since the end of 3.0 happened, we had a backlog of 80 or 90 issues at some point. And then we very aggressively just, as I said, spent 3 times a week rather than 1 time a week to just walk over the backlog to get more and more stuff approved. And the other interesting thing with the API review process is we very rarely refuse APIs. I mean, most of the time we would say, yep, the API generally is approved, but here are some tweaks for the shape we would like you to make. So if you submit API review requests, it's very unlikely that you get completely refused. I mean, we refuse things that are not in the spirit of the platform, but by and large, most issues are not like that. I think at some point I looked at the ratio and it's 99% is approved. But as I said, probably within the 99 percentile, 85+% is approved with additional tweaks. So we almost never take the API suggestion as is either. So there's that. So that's basically it. So if you're just curious what our backlog is, apireview.net, go to the page, view the backlog. So other interesting thing that I'm working on is we have this thing called roles and analyzers that in this release we're trying to extend what analyzers ship in the box. So today you can install a bunch of NuGet packages that will give you smartness in the IDE, basically analyzers that tell you you're using this API incorrectly, or the way you use C# is not quite right, make these tweaks to your source code. And for .NET 5, we basically said a bunch of these analyzers should always be on, basically. So we moved them from a NuGet package effectively into the SDK. So if you start a new project and you start writing code, they basically always run and make sure that you write quality code. And one of the key analyzers that we added for 5.0 was detecting platform-specific APIs. And so, as probably most of you are aware, .NET Standard has a lot of APIs in them that historically just are Windows-specific APIs, but they're so low in the stack that we couldn't quite remove them or make them NuGet packages without breaking a lot of existing code. So a good example here is all the file system ECL APIs that we have. They only work on Windows because that's just how Windows does permissions. And you shouldn't call them unless you only intend to run on Windows. And so in order for us to make this a bit more easy for people, we decided that it would be nice if we had an analyzer that would actually tell you when you're doing this. So I have a quick demo for this to kind of give you an idea what it is. And if you're curious, here's the whole spec in the designs repo that kind of outlines how the feature works. But basically the idea goes like this, right? So let's say you have an API. Think of this part here where I said Windows-specific stuff. You can imagine this being the registry or ECL APIs. And this could be a platform API or it could be your own API. And so a very common pattern here is you say, okay, I have to p-invoke to something that does something in Windows. And then you say, well, if I'm not running on Windows, I throw platform not supported. Otherwise, here's the actual implementation. And that's reasonable, except the person that called you doesn't know that, right? And so let's pretend right now I'm running this on Linux and I execute this code. I have to wait until VS wakes up. Here we go. You basically get a runtime exception, right? It just says, platform not supported exception, right? So if you, for example, try to open the registry on Linux, that's the experience that you're getting. And so people rightfully said, well, that's very unfortunate. I mean, if the API literally says Windows-specific stuff, then sure, but most of our APIs don't say that, right? They have innocent names like, directory dot, get permissions or something, right? And unless you know that this is a Windows-specific API, you're not going to, check for that. And so basically what we can now do is we can say supported OS platform on this thing, and we can say Windows. And so this will be something that, or I can put it here. Basically, that's what the API author would do. And we will do this for all the specific stuff that we ship in box. registry, ACLs, WinForms, WPF, all these ones are marked. And then what ends up happening is if you call this, you will get this this warning, right? And you get it basically in the IDE in terms of squigglies and tooltips, but you also get them when you actually build. So you literally get a build warning that says, well, you're calling an API that is marked as Windows specific, and your project right now, in my case, it's a .NET Core Console app, is cross-platform. So you should do something about that. And basically, you have two options. You can either say, I myself am Windows specific, so that means you mark yourself as Windows, which now means all your callers will get a warning as well. Or you can say, well, I do some extra stuff on Windows. So basically what you would do is you would just say, if operating system is Windows, we have a bunch of shorthands in the product. And then, as you can see now, the warning automatically disappears because the analyzer knows that this thing only executes when you're not on Windows. And it doesn't really matter how you write the code, right? You can also do things like this, right? Return, right? And then you also don't get a warning, right? So the thing understands your control flow and doesn't warn you when you're doing the right thing. And so that's actually kind of what we want to do. And then also the other thing we are going to do is we support version numbers here as well, which for Windows doesn't make a lot of sense because virtually everything we have is supported on, all versions of Windows that .NET can run on. But for iOS and Android, for example, the general pattern is you're targeting the bleeding edge, the latest version of iOS, but you still want to run on, 1 or 2 generations older because that's just how the device market works. And so in the same way that you get a warning when you're on Windows, you will start getting warnings when you call APIs that are potentially unavailable because you run on an older version. And when that happens, let's just simulate this here. Let's say that this is a 7.1 API. And then let's say I myself am marked as being Windows only, but I'm basically saying I'm Windows 7. And now when you call an API that says 7.1, you should get a warning. Maybe that's not in this particular build here. But basically the intention here is you will get a warning that says, well, you are basically saying you're running on 7.0, but you're calling an API that requires 7.1. And so similarly, you would get a squiggle here. And then basically what you would do is you would write your check slightly differently. Instead of saying is Windows, you would say is Windows. And then you can say is Windows version at least. And then you can say, well, how about 7.1? Right? And then same thing happens here. And so the intent here is that we give you the ability to call native operating system APIs very easily, but we also want to make sure that you don't have landmines in your source code where you accidentally call APIs that aren't supported. And so that's kind of the general pattern that we have.
So you might ask some questions in the chat, including somebody who wants to abuse your feature already.
Abuse or use?
Abuse. Yeah. So check that out.
Totally abuse the intent. I'm thinking to use this to write thread-safe code. You probably could do that because as far as we are concerned, they're basically just strings. But I would not recommend that because there's implications for the callers. So the other thing that we can do, which I haven't talked about, is you can also do the reverse. You can also say, let's say I have an API here. Let's say this is not Windows specific. Let's say this is a generic API, like threading, for example. And I can say, well, threading I can't do on certain platforms, right? So for example, let's imagine for a second we talk about WebAssembly, right? Where Blazor runs inside the browser. In WebAssembly, you can't create new threads. So let's pretend right now this is, thread create. And then this is threading. We can also say this. We can also say unsupported OS platform. And then in our case, you would say browser. So that is kind of the inverse of that. And so now if I actually call threading, thread create, I don't think our current build has that either, but like we will basically know whether you target browser or not. Yeah, here's a good example. So basically it says like, well, I assume because you're a general purpose library or general purpose application right now, we assume you want to target everything by default. And so that means if you call an API that is marked as unsupported on some platforms, you will get a squiggly as well. For browser in particular, we will tweak this because by and large, we don't expect most people wanting to run inside of a browser. And so we will basically say by default, when you create a .NET Core console app or a .NET Core class library, we will say, well, we assume you want to target, the common platforms like, Windows, Linux, iOS, macOS, Android. But some of the more constrained environments where you have to do more work, we will not necessarily opt you in by default. And this could be, for example, watchOS because it's more restricted, right? Or in particular, WebAssembly, because a lot of the things that work everywhere just don't work because of the browser sandbox. And so we don't want everybody to have to deal with these quigglies for platforms that you are very unlikely to target. And the idea here is that in the project file, you can select by saying, okay, this one I actually intend to run on browser. So you would just mark the project file and say, I would like to support browser. And in which case you would get these quigglies. But as I said, this is an early build, so it doesn't have that feature yet. But that's kind of the idea.
Martin wants to know if the linker is going to remove the unused code on platforms where it doesn't make sense. Is that
that's a good question. I think the idea there is yes, so long. I mean, the tricky thing with IoT is like it depends on how portable you want the outcome to be, right? So if you basically say like, of course you expect when you compile for iOS to not have Windows-specific portions in your code, right? That makes sense, right? But for example, in iOS, if you build for, let's say, iOS 10, what do you want to happen for code paths that are on iOS 11 or 12? Generally speaking, you want to leave those in, right? So you can't just naively say, everything that is outside of what the IoT toolchain was building for is unreachable, right? So generally speaking, later versions should be considered reachable. And so that's kind of the challenge where we have to like be somewhat conservative as well. But yeah, I would generally expect that other platforms will be linked out.
All right, cool.
I just shared a link that related to Martin's question. There's a mono issue that we created last kind of November timeframe that talks about those things.
So it's not.
I did have one question for you, Emo, which is.
I was going to say it's not obvious to me where the link is showing up. New tools, folks. Sorry about that.
I don't know why it's not showing up in this comment section, but I put it on. It's on the YouTube place.
Oh, I see. So yeah, maybe I don't see it here yet either. But
maybe, you can send it to Emo, and he can make it one of those little running banners across the bottom.
Well, it's. I'll just tell you what it is because I have two computers going. It's on the other one.
Which is the issue number?
It's in the mono. Yeah, it's in the mono repo, and it's 17823.
All right.
17813.
I had a question for you.
23.
Sorry, 17823. Does that look related to you?
GitHub.com/mono/mono 17823.
Yeah, and it's an issue, not a PR.
Oh, sorry. It's me being idiot. I need to insert /issues. Turns out I don't know how GitHub works. All right, so let me now figure out how I can actually add this. I think it is like that.
Hey, look at that. Yay. Cool. We're getting the tool. Yeah. I like this new streaming tool. So
it's very nice. I mean, they did a great job.
We're going to have a couple of hiccup or two.
So I do have a question for you, Emo, which is, you talked about how there's all these APIs in .NET Standard and .NET Core that are like Windows only, particularly for .NET Standard. So was that a mistake? How do we feel about that, N years later?
So I would say in the grand scheme of things, it's a mistake in the sense that if we were to redesign the APIs from scratch, we wouldn't do that. And by and large, we have not done this for net new APIs. It's not a mistake in that, some people said we should remove those APIs from the standard. We think that would be a mistake because basically it means everybody who is targeting Windows is now basically penalized by having to rewrite their code to use new APIs. And that would effectively break the library ecosystem and all the existing apps that are already out there. And so that's why I think that's more like a reasonable compromise. to say like, okay, nobody wants hidden landmines in their code where stuff just blows up at runtime. We would like to know it compile time and stuff doesn't work. But I also believe removing an API isn't necessarily as helpful as this quickly that tells you, okay, I know what you want to do, and I can tell you that it won't work because of your configuration, right? That is much, much more actionable than just a compile error that says, sorry, I can't find, directory get permissions, for example, right? Because then it's like, well, what API am I supposed to call? Like, how would I know that? And so in that sense, I think it's more practical to just say, let's deal with the way, let's deal with the code people have already written, and let's just make sure that idiomatic ways of doing things, like, for example, checking version numbers or checking which operating system you're on, will just continue to work fine. And so I only demoed the new way to check for operating systems, but we will also support the old way of checking for operating system stuff. Like, for example, when you go to runtime information and you say, is OS platform Windows, which people have done basically since .NET Core v1, that code will also be recognized as being valid, right? So we will try really hard to make existing code like do the right thing, by also making sure when you write net new code, you're not going off the rails and you're suddenly make something less cross-platform than you intended it to be.
Cool.
Everybody nods in agreement.
Yeah. Yeah. So you want some, you said you you said you didn't have much. That was pretty good.
Yeah, thank you. We worked on it for a while. We're very happy about it.
Oh, I had one more question about that, which is, sorry for the planes flying overhead. So with those versions, particularly like the Windows one, it would be interesting if our guidance was to match the Windows version that you would see in the TFMs.
Right.
Which you could point to if that post had been published. It would be weird for us to advocate for people to use multiple different versioning schemes for the same OS.
Yeah, so the version number is basically the version number that the OS has, right? So in that sense, it's not up for us to decide, right? If the Windows has 10 point 0 point 4-digit version number, whatever it is, right? By and large, the one thing we have done is for things like Windows, usually we don't put a version number, which is basically to say you're basically saying 0.0, right? And so that's technically not true, right? The Windows registry isn't supported since Windows 0.0. But when you say 0.0, it means if you check for whether you can use the API, it means you don't have to check for the version number, right? So if you just say if operating system is Windows, that's considered sufficient to check for the API because it's available since 0.0. If you would have said, sorry, the registry is available since, I don't know, Windows 4 point something, right? Which is probably true. Then you wouldn't get away with just saying it's Windows. Now you would have to say, is Windows version at least 4 point something? And given that we don't support these old versions of Windows anyway with .NET, the minimum we run on is Windows 7. We can basically say anything that is Windows 7 or earlier, we don't put a version number because it means you don't have to check for the version number, right? But if we add net new APIs, let's say we add some WPF or WinForms APIs that only work on, let's say, Windows 8 or Windows 10, right? Then we would start annotating them with the correct version numbers because you could run on Windows 7 where the API isn't, right? And then you would have to actually write a version check for that. And so that's the general pattern that we have. Same with browser. Browser doesn't really have a version number either, right? Because it just is indicative of the sandbox for the browser. That's why we generally say unsupported OS platform browser rather than browser 1.0 or something like that. And so we try to minimize the places where you have to do version checks because nobody likes version checks. But we also want to make sure that you write correct code, right?
Now, it's a good question about what about deprecating the older APIs?
Yeah, so I basically showed two attributes so far. I showed supported and I showed unsupported. We also have obsoleted in OS platform, which is kind of the same thing as obsolete, except that it's basically conditioned on the version of the platform. So the canonical example here is iOS. Let's say, for iOS, the expectation is the latest version of the iOS SDK will have all the APIs that iOS has, or the current version of iOS has. But you will also be able to target older versions of it with the same SDK. That's why we basically have to indicate that, if Apple, let's say, removed an API, it would start marking the API as unsupported OS platform for that version number. And then in the same way, usually what Apple does is they will first obsolete or deprecate the API. So we would usually start with obsoleted in attribute, and then later on, if they actually physically remove the API, we would then say unsupported. And so the idea is, yes, if you call an API that is considered obsoleted, you would get a normal obsolete warning that you get today, but it would be conditioned on what platform your project configuration says you are supporting. And so if you bump the version number to something higher, then you will get it. If you bump it for something lower, then you don't get it because it wasn't obsoleted yet.
Right. I think the question though might have been more related to, like, say, those ACL APIs, basically the APIs that require this platform checking.
Right. Yeah. So
Well,
is that, like, is the question is, are these deprecated or?
Well, I think this is how I'm interpreting the question. It's like, we included these APIs because they were already on those types, and it would have been really harmful to compatibility. And as a result, we kind of we're investing in this analyzer,
right,
to make the experience better. So why not just deprecate them? And so my expectation.
Oh,
so
I see.
Tell me if I'm wrong. Is, well, those APIs still have a use. They're just Windows specific. Right. And if we were to deprecate them, it means we would have to move them to a different type. Yes. That was Windows only, and that would be a mess.
Yeah, so that's kind of, that's basically the point, right? If you look at the registry, for example, the registry, I would argue, is a very good API for the Windows registry, right? There's nothing wrong with the API, right? The API is fine. It's just a question of, like, should you be able to use it when you're building a .NET Core app by default? And then if you say no, well, then what's the solution, right? Then you would say, oh, you have to target net5-Windows to use the registry APIs. But that's not how the world previously worked, right? So then we would have to effectively break compat with net standard to pull that off. And that seems more harmful than doing the targeted thing. But even, let's say we were to do that, right? Let's say even we would be willing to do that, then we still have to solve the version to version issue, right? Because we don't want to give people dedicated API sets for every version of iOS and Android. We generally want people to be able to use all the APIs, having a single application, and then within that application, just say, well, if you're running on iOS 12 or higher, there's this new feature that I would like to use. And so in order for that to work, we would need an analyzer anyways. And so we basically said, well, if we do version-to-version analysis, then doing platform-to-platform analysis is basically a freebie, right? You don't have to do extra work to pull that off. And so I think the experience that we have solves both things very neatly. But the idea that we can just remove things doesn't really scale if you have to support multiple versions of an operating system, especially once you don't get to control, right? I mean, we don't get to tell Apple what to remove, right? They just do whatever they feel like it, right? And we just have to model that in our tooling.
All right. Well, I got a couple of things I want to talk about. I don't have a good demo, although I'm going to put something. I think I'm going to share something, but the actually, I have to figure out how to get this. Oh, wait. Okay. It says it requires 2 monitors. I'm not going to do this. I'm just going to give folks the link. So, Emo, I posted it in the private chat, if you can put that link up. So one of the things that if you work with MSBuild, you wind up using is bin logs. Bin logs tell you what's going on, but they're these giant icky files. And so we've got something called the bin log, the structured bin log viewer, which has been around for a while, but it's Windows only. So what we've got now, and this is our great intern did this, it's a really nice project, is there is a viewer in the cloud now. And so it's a web browser. And so you can hand it a file and it'll open it up. It's in your browser, not the cloud, but yeah. Anyway, you can open it up. You can look at your bin log. You can do the things that you could do previously in structured log viewer on your Windows machine, but now you can do it in your browser, which means you can do it cross-platform. And so anyway, we're super proud of that. And don't miss that for those of you that love it, up in the upper right corner, there is a dark mode button, which was the last thing that she was able to add. So I'll demo that next week, but I don't have a good bin log to show you. And I want to make sure I get this whole share screen done ahead of time. A couple things, if you're a System Command Line fan that we're working on, I just want to mention app models are moving along. It ran into a problem with binding, so we've unified the binding. And I'm super excited that PR hopefully will go in this week. And we also have a PR for localization. Super excited to get that done. And then finally, I'm definitely interested in folks that care about our releases.json file. I know you don't know what that is to start with, but this is the way that we put out the what new runtimes and SDKs we have available. And we have it in a file called releases.json, and there's a releases.index.json as well, which is a shortcutted version. And we are looking at possibly putting an API and maybe a global tool on that. And it would be super helpful to understand how people would want to use that. So our expectation is that you could ask questions like, is there a new update? And that's what we're thinking in terms of. And I'd love any feedback, any questions anybody has, anything. I want to do this with it, and we'll try to make that a supported scenario. So this is stuff that we're doing planning on right now and in a planning state. Obviously, feedback on how somebody would use this new feature would be extremely helpful. So if you think that you would like to have an automated way to find out what releases are available, it is one step. Overall, we're looking at acquisition. Overall, we're looking at making your life easier to both put things on your machine and take them off. This is just this one step of understanding what's actually in our main feed. And I don't have a link for that, but I can get one in just a minute, and we can put it in after Philip starts talking. I can look it up, but I don't have that ready. So I got circuit log viewer, updated system command line coming, and releases.json. We're looking into an API and global tool on that, and that's kind of what I got today. It was short and sweet. I hope it was sweet. It was short.
Makes sense.
All right.
So, do you have a link that I should put up?
I'm working on it. I'm going to put it in the private chat. Just as soon as I get it, you can throw it up. Okay?
Sounds like a plan. All right, Philip, then you're on.
Okay, all right. So I'm now sharing my screen. This is our demo that we have for, all right, so I want to talk about some F#5 stuff. I've been mentioning that pretty much every time for the past pretty close to a year now. We're getting really close to locking down on F#5. I think the last set of language features are now in. In being relative, one was merged in like a week ago, the other was just a few days ago, and so the one that was just merged in a few days ago, nobody has access to yet, but including even me, because it hasn't plumbed through some of the stuff that we've been doing. But I want to show kind of a little bit of what the F#5 stuff is, and I'm using VS Code here, VS Code Insiders, and this is VS Code Notebooks. This is visualizing the Johns Hopkins COVID-19 time series data. So first, I'm actually going to execute some PowerShell. So this notebook is actually it's powered by a kernel that is multi-language. It includes F#, it includes C#, it includes PowerShell, it actually includes HTML and JavaScript as well, and you can kind of mix and match some of that stuff. So all this does is just download some CSV files, because if you just want to do something like download a file, PowerShell is really, really succinct for that. Next, I'm going to write some F# code here that extends the system collections generic list and adds this API called getReverseIndex. This is an F# preview feature. It allows you to do what we call negative indexing into a data structure. So that's just a cell. I can click this to execute it, or I can hit Shift Enter, and I can mix and match F# code with Markdown. So all this did is just define a little thing that I can use later. Now what I'm going to do is I'm going to have some F# code that uses some regexes, and all it does is just read in a given file based off of its path. It runs a regex over it, and then it writes the clean data back into the file. So I'm going to run this clean function on these 3 CSVs that I just downloaded. So it's going to do that, and then it says all cleaned up. All right, cool. So I've stripped out some bad stuff inside of those files. We go here. Now they kind of look like this. I have a Rainbow CSV extension installed, so it looks all pretty. So now we're going to load it into a data frame. So to do that, I'm going to need to incorporate a NuGet package. I'll just go ahead and do that. Notice that the syntax was #R NuGet : name of package, comma, version number. I actually don't need to specify the version. I can actually just write it out like this, but I chose to specify the version because, you know, whatever. And then I'm just going to go ahead and open that the main namespace there, data.analysis. So now this is it. This is actually pretty interesting because if you compare this to the Python world, let's say you're doing Jupyter Notebooks in Python. You cannot write code this simple to incorporate a third-party package. You actually need to new up a, I think it's like a pipenv or something, or pyenv. There's like multiple of these things called environments in Python, and they're kind of annoying. And if you don't do that, then you're actually not being safe, and you could destroy something on your system. We don't have that problem in F# and .NET, so it's really trivial to incorporate a third-party package into your notebooks and get going. So what I'm going to do is I'm going to have access now to this data frame type. And I'm just going to load those things up into you know, the data frames from, there's this API called loadsDSV. It loads it into a data frame type. I'm then going to display something that's going to say, hey, we're doing some stuff. And then I'm going to new up a resize array, which is the type abbreviation for system.collections.generic.list. And then I'm just going to go through the number of columns, and I'm going to construct some data. I'm going to get a date. I'm going to get the number of filtered deaths confirmed and recoveries for that given date. I'm going to then display something saying that, you know, hey, here's the date that we're processing. And then I'm going to construct some data with a series of nested anonymous record types. In this case, there's just going to be a date. There's going to be a death series, a confirmed series, and a recovered series. And that is going to be added to another series. So it's basically going to be like a series of series that I'm adding in there. And then when I'm done, I'm going to press done. So I'm just going to execute this cell. It's processing a bunch of dates. And it's done. All right, cool. So now that we have this data, we can decide to chart this data, which is where things get a little interesting. So I'm going to be using a plotting API called Plotly, which actually is a JavaScript API that we have some .NET bindings to. And first, I'm going to construct what's called a layout. A layout is just sort of like laying out sort of general stuff about the chart, that, you know, how you want to visualize it, like what's the font, what's the title, or what's the background color going to be. There's an option called a geo, and there's some for like showing like a globe in a chart, and then you can show some, you can have some specific settings for the geo settings and so on. And it's taking in date as input because I actually want to, as a part of the title, throw the date on there that I'm looking at. So then I'm actually just going to look at confirmed data. So if we look up here, there were, oh, sorry. I'm just constructing a series of confirmed recoveries, basically, that I have here because I like good news. And so then I'm going to be doing a little negative indexing here, actually, or reverse indexing, I guess you could say. And so I'm going to be looking at the series, and I'm going to take the item that is 0 from the end, and then I'm just going to get the latitude, the longitude, some of the data. And I'm going to construct this thing called a marker. And this is going to be what's called a trace. And a trace represents, it's sort of like the data frame that we had before, except it's going to be a plottable data structure. So then I'm just going to pipe that into the chart.plot function, and I'm going to pipe the results of that into the chart.withLayout function. And then the layout is going to take in whatever the date is. So I'm going to execute that, and we should be able to see an inline chart right here. So we can look at COVID-19 recoveries for 8/12/20, at least in the data set that I have. And you know, you can do some fancy stuff right here. I think I can actually download this as a PNG if I want. Produced with Plotly, there's, you know, I can zoom in, take a look at some stuff. I mean, this data, like, you know, there's ways to clean this up so it doesn't look like garbage the way that I did it here. But the point is really that, you know, you can display some stuff on the map and you know, cool stuff like that. So this is just like a small preview of some of the interesting stuff that you can do in VS Code notebooks today. There's a little bit of stuff going on here with some JavaScript that I haven't quite gotten to work yet. But we can do some other interesting stuff. So I'm going to construct another thing called myValue, and it's just going to have my name on there. And then I'm going to construct an HTML target. Note that the cell right here says HTML.NET Interactive. It does not say F#, it says HTML. And then here I'm going to have JavaScript. And I'm going to get the element by ID that I called target. And then I'm going to call interactive.f#.getVariable myValue. That's going to be a promise, and it's going to set the inner text. So now if you notice, that used to say HTML, now it says Philip. So this is actually some cross-language interop that we have here, where this F# value in the notebook is actually serialized with JSON.NET into JSON. And then we can then extract it from JavaScript because it's just JSON, which is pretty neat. So then we should also be able to do some basic stuff like that between F# and C#. So here I have a value called doot, and it's going to take the string value doot. And then I'm going to do what's called variable sharing, where I'm going to share doot with C#, and I'm going to display C#. And there we go. It was able to display doot from C#, but this value was defined inside of F#. Now I'm going to do the inverse. I'm going to define a value called toot. Sorry, it needs to be toot. And then I'm going to share from C# the variable toot. And I can do the same thing. So we have value sharing between F# and C#. And there's a few limitations. Like, for example, say I defined a data structure inside of C# and I tried to share the value of that data structure with F#. F# is not going to know what that data structure is. And then vice versa, right? Like if I have an F# specific type and then I choose to share it with C#, but the C# doesn't have the definition of that type, it's also not going to work. But for values, like actual just shareable values, those are trivial to share now. And so it's done with this little shebang that we call hashbang share. And this is an area that we're working in a lot in the notebook space. So it's pretty cool. It's still all in preview. The way that you get it right now is by using the VS Code Insiders install. And then all you actually have to do is install the .NET Interactive Notebooks plugin. And this will install everything that you need to have to be able to do this kind of stuff. And it's updated very, very frequently. So you can get the latest, hottest bits. Speaking of the latest, hottest bits, here I have Visual Studio. I'm going to set this interactive session here. Okay, so this is a preview of Visual Studio. This is actually, I don't think this is accessible to anybody except for internal to Microsoft. I want to share one of the features that we just now
secret stuff. Now we're getting somewhere.
Yeah.
Secret.
Exactly. It's not that secret. We dog food. We talk about it all the time. So we recently released string interpolation for, so I shouldn't say released. We recently merged string interpolation into F#. And so you can do some pretty basic stuff like, say let. There's still like a few little rough edges here and there because, this is the very first version. It's the very first integration in Visual Studio, but it's actually in a pretty good place. Like, I could say my age is, and I could say 12. And my age is 12, so I'm 12 years old. Isn't that nice? Then I can say name. And now I can change this a little bit. I can say my name is. I should put a space there. And my age is 12. One thing you'll note there, I can do things like go to definition. I can rename it, I can sort of do what I want there, which is pretty cool. I shouldn't hit save. I'll go ahead and execute that in F# Interactive, and now it says my name is Philip Carter and my age is 12, which I think is pretty accurate there. It's got all full IDE integration inside of these values, kind of as you would expect inside of Visual Studio tooling. But you can do more.
Wait, there's more.
So first of all, I can turn this into a triple quoted string, which is the F# way of specifying. So like I can do things like like this. right? And so I can put like quotes inside of quotes and that sort of stuff. Basically, the way, whenever you have like these kind of more complicated string literals that you're working with in F#, you always specify a triple quoted string, and that will sort of do it there. But we can really go wild with this. Okay, so everything that's inside of one of these interpolation contexts is an expression. So I'm just going to define some functions. Okay, and we'll go let odd squares x's. And we'll go x's piped into list.filter is odd, and we'll pipe that into list.map square, and then we'll call odd squares with 1 to 10. Let's see here. Cool. All right. Oh, there's some little indentation warnings going on here. Let me fix that. Now we're getting into bizarre territory. This is not something that people would actually normally do. But so I've defined a series of functions that I've then called with a value inside of an interpolated string in F#. And so you cannot do anything reminiscent of this in C#. It's not really the kind of capability that I would say is going to be terribly useful for people. They're mostly just going to be logging values inside of their strings there. But it's actually pretty fun. And on top of that, I can actually just go ahead and reset this interactive session. I can set a breakpoint, and then I can start debugging. And so I'm gonna, bear with me, I have definitely not tested this debugging an F# script in the dog food build of VS with a program inside of my interpolated string. Okay, so it was able to pull up the values there. This is pretty good. Let's see if we can, okay, I can step in. That was nice. I could hover over X. X's length is 10. So it seems like debugging this program that I've embedded inside of an interpolated string works. So I'm going to close it out before I embarrass myself any further.
So one question I have is, like you said, you can't do this in C#, and I'm not entirely sure I understand what you mean by this. Like, you can totally put arbitrary expressions in C# as well, right? Is the point more like you don't do statements?
Can't. You definitely can't. You cannot do statements. You cannot define methods. You can't define delegates. Like, it's very restricted what you can do in C#.
Yeah, that's what I mean. You can do expressions, but you can't do statements. I guess that's what you mean, right?
Yeah, you can't do statements. You can't embed like functionality itself. Like, you can't define, for example, a function inside of a C#, or sorry, like a local function inside of a C# interpolated string context. Like,
right.
You just can't do that. You have to define everything outside, and you can potentially call it inside of the string context. But
Gotcha.
you also debugging is different. So you know how I set a breakpoint here, or yeah, that case is a little funky.
Yeah, that's right. You can't do that.
Yeah, you can't like set a breakpoint inside of values that are defined inside there because because there's no statements. So like there's like not really anything to debug per se.
Right.
On the C# side. But so yeah. Anyways, you can have a lot of fun with these. We like to call this orthogonality as language designers. And yeah, that's pretty much all I got to share. There's some other features as well. We released. Sorry, didn't release. We shipped. Merged open type declarations. So it's similar to open static classes in C#, except there's a few additional things you can do. And we finished up some of our changes that we wanted to do to name-ofs. So we can have a slate of 3 things that are going to be coming out into the next preview. And we don't intend on putting any new features in after that. So pretty much from the next preview, there's new features, and then from that point on up until the release, we're just going to be in locking down bug fixing mode for F#5. And so I think I'm gonna, how do I stop sharing my screen? Stop screen, there we go. Cool, that's what I got.
Did we lose?
Yeah, I was about to say that because now there were some questions in chat that I wish he could answer. So one question was, Is there a Git repo for the web-based binlog viewer? Like I don't know the answer to that, but there is a generic repo for this. Let me just pull up the URL for the binlog viewer, and there's probably a branch would be my guess. So the generic URL is this here right now. So this is the generic URL for the MSBuild structured log viewer. It's done by Kirill Ozenkov, a guy on our team. It's amazing. It's really nice visualizer, and I would guess that there's probably either a discussion there somewhere, or at least that's where you could ask. And then there was this other file that Kathleen talked about earlier, which was the the index.json file for the releases, which you can find here. It's in the .NET Core repo.
One piece of information on that file is it totally does exist there, but it also a variant of it exists in Azure Blob Storage. So if you're going to use this for any sort of production purpose, we'd actually recommend you would use the one Azure Blob Storage. Probably just has a bit higher availability, and many fewer people can touch the one that's on Azure Blob Storage. So
awesome. So we just got our friend Kathleen back. So Kathleen, can you answer this one here? This question?
I'm totally lost, so I'll catch back up. I was just looking for that and did not find that, Martin. I'm sorry I don't have that. I'll continue looking for it, which is what I was doing before I got distracted trying to get back online. So yeah, I'll try to get that for you. Sorry.
And then Rich, you mentioned there was a question on records.
Yeah, so there was a whole conversation that I was having with someone about structs versus
right
classes. And so I'll just quickly tell you what I said, and then
this was your comment, right?
This is a what's this is like a perennial type of question with .NET. And when I first started using .NET, I was actually a little bit or quite confused about this. So the question was, I have one question with struct and class. Is there a difference in performance in C# or .NET and security, or can please tell me, I'm paraphrasing. Yeah, please tell me the advantages and disadvantages of using struct over class. Thanks. So I said, struct versus class is related. How do you want the included data used? If you want the same data to be used in multiple places, then a class is better. If the data is temporary, then a struct is better. And then I said, you can look at examples of where we've used classes versus structs recently and see if you can explain to yourself why a struct or class was used. And then the default answer is always class, and then you can convince yourself that a struct is better. That's the model used in the .NET team. And then there was a question. How does records change that guidance? That's what Douglas asked. And then I said, good questions on records. I haven't played with records yet, so I cannot answer that. I think records fall closer to scenarios where you would use immutable collections and friends. And that's where it ended. And that's where I'm looking at the language experts on the call to help continue the story, because it's a good conversation.
Yeah, I don't know the answer to that. I think I don't know, honestly. Like, I don't know enough about records. I think originally there was a design point where you could choose class versus struct by the way you declare the record. I'm not sure that's still the case.
No, there's no struct records in C# 9. That was scoped out. There's a whole other set of design concerns around that need to be hashed out. I mean, I think really the answer to this is records provide a very obvious improvement for one of the most common uses of C#, which is defining just data inside of the class with properties. And it sucks. It's boilerplate, and records make it so it's not boilerplate anymore. And that's, I think, something that a lot of C# users are going to love. Beyond that, I think we're really going to learn more from people. Like, I mean, that one feels pretty obvious. There's some additional stuff you can do with immutability and with expressions, and maybe there's going to be some people who are going to take that and run with using it with other immutable types and that sort of stuff. But we're going to have to wait and see, I think. Also, it can be a little difficult to gauge because we're only now just starting to incorporate records into other parts of the framework. So, ASP.NET MVC is going to be coming out with some initial support for being able to define records for your model binding types. And, there's going to be a round of feedback with that. And, there's some specific limitations with how you can do that today. And, it's kind of, we don't really know if those limitations are really going to hamstring people or if they're fine. And, there's just additional things that we could do. But yeah, I think, first of all, there's more that can be done in the records design space already. And it's likely that there's going to be more work done in records and subsequent C# releases. But what influences that work is going to be based off of the feedback that we get. And I think that was one of the goals is, here's kind of like a nice, fairly simple core design for records is shipping in C#9 that improves some very obvious use cases. But then, users are going to be able to take that and do some interesting stuff with them, and that'll sort of influence where we go from there.
Speaking of C#9, sorry.
I just want a follow-up question on that, which is, I was saying that records were more aligned with immutable collections and friends. And you kind of touched on that, Philip. Is it fair to say that the first thing that it kind of replaces or touches before immutable collections is more like tuples? In terms of like, sometimes I've used tuples as like a temporary, very, supposedly lightweight modeling system so that I don't have to define a class. Does it replace that use case scenario?
Kind of. Yeah.
Go ahead, Kathleen.
Part of the design goal is that it's a smooth next step. It's got a few more features than I think you're going to get in some of the, I'm not sure the comparisons and all, the shortcutting and all that, I'm not sure all that may be better in records, but basically if you've got a tuple and it's getting big, it should be a straight line to getting records and similar functionality there.
Yeah, there already is a quick fix in the IDE, right? If you have a tuple, you can control dot onto it and it will generate you an actual type with the proper declarations. And the problem is that when you do that, as Philip said, it will generate a lot of code, right? Because it has to like basically do equals and get hash code and all of that, and that's more code than you want. And if you do the same thing with a record, then it's basically just the record declaration plus the properties, and that's pretty much it.
You don't have to write that code; it happens for you. So yeah, I do have an answer for Martin, although it's not the world's greatest answer, which is that I'm going to give you the main structured log viewer link. Okay, and Emo can put this up for the repo, and then our Lauren Prin, our great intern, forked this, and so I'm sure we're going to put it back into this repo is my expectation. And I kind of hesitant to put the link to Lauren's fork in when I expect it'll be evolved on Carol's fork. So on the main, it's not the fork, the main one. And so I'm a little hesitant to put that up because it's kind of temporary. So
I already put up the Kirill Ostakov's main one earlier, and I said that's the mainline thing, and I would expect that to eventually land there. So
it will land there.
And we already have that.
As far as I can tell from the little exploration I was doing in the background, sorry, I didn't know that off the top of my head. It certainly looks to me like this is not a whole different thing, that she forked it, and my expectations will go back in. Unless I found the wrong thing, in which case we'll get a note both in the link I gave earlier and in the GitHub repo, so that people can kind of find which one they want to look at. And somebody asked something else about it, like color, and it's open source. So if we can move forward on some extra features, we're all for that. Right now, the goal of the online log viewer was to hit the same basic functionality as the Windows one. We did do a little bit of work around icons, because I was like, yeah, colors aren't good enough, because we want to be a little bit more accessible than that. So we did get some icons in, but overall, it's just a new version of that runs in the browser. All right.
Yeah. So one question, like on the follow-up one to the C#9 discussion. So Mark was asking, if I can actually click on it, here we go. Any guidance on debugging source generators? Philip, this I think is your question.
Any guidance for debugging source generators? I guess it depends on what you're trying to debug.
Yeah, I mean, like what I usually did is I did exactly what Mark is doing. You just use debugger launch because when you're actually running inside the compiler, there's no easy way for you to set a breakpoint otherwise. The problem is VS. If you run inside of VS, there's not much you can do. You have to relaunch every time you make modifications.
This is something we're going to look into post C#9, post VS 16.8. I mean, there's some ideas for how to do it. It's just really complicated. And so, it's kind of annoying, but that's really the best we got for now.
Yeah, I mean, ReSharper should be able to use them. So basically the follow-up that Martin has is like, source generators do need some like experience tweaks, and ReSharper should be able to use them as well. I mean, they are. I mean, it's just it's similar to an analyzer. It's a plugin to the compiler. And to my knowledge, they already support analyzers. And so, yeah, supporting generators is something that they can do. I mean, my understanding right now is that we don't have a lot of the experience tweaks in VS either. They're still coming in, right? But like that's the expectation is that it should just work. But depending on how they populate their compilation context for IntelliSense, they may have to do extra work to do that. It's similar to what we have to do for Visual Studio.
Yeah.
All right, then this is it basically.
We're over. As usual, we've run long.
Then I would say this is it for everything we have. And you can find all of us on Twitter pretty much. So you can harass us pretty much 24/7 with questions, and we usually are good with giving you answers.
You might have Richard's name though. I'm not sure he's on. I'm not sure you're going to find him on Twitter if you do Riched instead of.
That might be true.
Yeah.
All right, everybody, wave and say goodbye. Bye-bye.
Bye-bye.
Bye.
Bye-bye. Thanks for watching.